Hello friends, welcome to the second lecture of Cisco Packet Tracer, that is a network simulator tool. In this lecture we are going to discuss about the LAN simulation, how we can simulate a LAN using hub and switch connecting devices, and after a brief introduction of hub and switch and their difference. So let's start the lecture. Here the outcomes of lecture are going to be star topology. What is a star topology? Topology is basically the term used for the physical network structure. So how the network is physically laid. So here we have two devices to connect nodes in the network, that are hub and switch, and the difference when to use hub and where we require switch. And in last we will be having a hands-on session for LAN using hub and switches. So first is star topology, where the systems are connected in the form of a star. Means we can say that all nodes are connected to a centralized node. So every communication is done through the centralized node only, and this node can be a hub or a switch. And here the centralized system acts as a server and other systems are acting as the client. Okay, means every request will pass through the centralized system only. Next, it is the most common network setup that is used nowadays for any organization or any institute, any university. Everywhere star is the best topology to use, because here we have the freedom to add or remove devices at any time without affecting the network functionality. So here the central node device is the medium of communication within the complete network. Next we have the extended star topology. If we have more number of devices to connect, then we can connect any number of devices with star topology, but we need to form the hierarchy. Means if we have connected 3 devices with a switch or a hub, so one of that device can be a hub for further network. So we can create the star topology in hierarchy or in any way. Like here we have connected one switch with this server or any system, and this switch is connecting this and this. So we can have the structure in any format using hub and switches. Let's discuss the features of hub and switch separately. Hub is like a simple USB port, multiple USB port provider that we have normally used. So here we connect this USB to our system and we are provided with multiple USB ports. So if we are connecting the device at this port only, then the data is active for all the port, but only this device, the connected device connected at this port, will respond to the request and request from the server. Means copy, paste, or anything that you want to perform. For networking we have this type of hub where we have these Ethernet ports. These Ethernet port is used to connect different devices, different nodes to the network, and those nodes can be same or can be different. So here hub is a device that works at the physical layer and it forwards the packet to all connected computers. So hub is doing no check, it simply receives the packet from one system. Suppose we have connected multiple systems here, so hub is receiving the packet from one system and forwarding to rest of the system. Means if a system has sent a packet for this D system, then hub will forward the packet to all these systems, and only the destined system, means where the destination address match, will accept the packet and others will reject the packet. We will see this when we perform the simulation with Packet Tracer tool. Next we have the switch. So switch is basically like the hub, functioning is same. It is used to connect devices in the network, but it works at the data link layer. Okay, it works at the second layer of the OSI model, at data link layer. So it forward the packet to specific connected computer only. Unlike hub forward the packet to all the systems, it performs broadcast always, but switch can perform intelligently and send the packet to the specific connected computers only. Like here we have connected the system A, and here we have multiple systems connected with the Ethernet ports. So if the packet has the destination address as this P, then switch will receive the packet from A and send the packet to P only, and after getting the acknowledgement back from the P, it will send the acknowledgement to A only, not to all systems. So this is the way how switch works. Now let's have the difference of hub and switch. It works at the physical layer, switch work at the data link layer. It perform broadcast always, it perform unicast, multicast, but switch can also perform broadcast if required. It is a passive and dumb device, as it is not performing any task intelligently. It is simply receiving the data and forwarding the data to all. So hub is like a repeater, only a hardware repeater, but switch is working intelligently, an active device, so it is forwarding the data to specific systems only. So it has some software to administrate the task, but it doesn't use any software, and the speed is limited to 10 Mbps. Here the speed is 10 Mbps, 100 Mbps, or it can go up to 10 Gbps. So these are the basic differences for hub and switch. Let's have the practical demonstration how a network can be a star topology network, LAN can be laid, and how the communication goes on with broadcast hub and with unicast and multicast of switch. So let's have the practical session with packet tracer. I hope you have already installed it. So I have already installed and login for this packet tracer. This is the interface that I am getting. So now I am going to connect two systems. So here we are, if you see, if we have all the devices available with us. Suppose I want to connect 3 systems with the hub, then I will be using hub. Simply search for the hub, and here is the hub. Okay, so I have got one hub. Now I need to connect 3 end users or end system. So one is our PC, and I am getting second as my laptop, third is again a PC. So I am using distinct devices just to make the variation in the network. So all these devices are going to be part of one network. So we just quickly connect them together with hub. So because single point of communication is through hub only, but as we want to connect different devices, a system with the hub, so we will be using straight through cable. Unlike peer-to-peer network where we were connecting the same devices with this crossover cable, but for this star topology, as we have different devices, distinct features devices, so we need to use copper straight through cable. So here fast Ethernet 0 is connected with fast Ethernet 0 of hub. As we connected, they got configured, and we are getting the green dots here. If it is taking time, it may take some time, then initially the dot can be red, and after that, after the configuration is done, then the dots turn to red, from red to green. So here next connection, fast Ethernet 0 to fast Ethernet 1, fast Ethernet 0 to fast Ethernet 3 or 2, sorry. So here you can check, we have 6 Ethernet ports in our hub, so we can connect the devices to any of these Ethernet ports 0, 1, 2, 3, 4, 5. Okay, they every numbering will start, index will start from 0. So we can also change the labeling of our system. System 3, let's use the unique names only. System 1. So labeling is done. Let's configure the IP. So for PC1, I am going to give the class C addressing. So class C addressing start from 191. I am going to give 192.168.12.12.1. So for first system, I have provided the IP as 192.168.12.1. And if you check again, the subnet mask is taken automatically. Once I added the class C address here, as class C address has network ID of 3 byte, so subnet mask of 3 byte is added. It has already taken the network ID as 255 or 3 byte network ID for class C addressing, and subnet mask is set. Next, we can copy this network ID for next system. So here we are setting the next system with the same network ID and distinct host ID. So host ID is 2. Okay, so 8 bits are used for defining the host ID, and if you click here, subnet mask is taken automatically. For third, it is 3 now, and subnet mask is done. Okay, so here we have configured all the devices. Let's check whether system 1 is able to communicate with system 3 or not. So here we will be using the same scenario with ping command. So let's open the command prompt of system 1 and run a ping command from system 1 to system 3. So for that I need to type IP 192.168.12.3, as I need to check whether the system 3 is connected to system 1 or not. So here, yes, we have got the reply from system 3 as successful. So 4 packets were sent successfully and received acknowledgement was received successfully. That means our communication is done. So here we can also check by sending the packet unit. So we call it PDU here, that is packet data unit. Add a simple PDU. This is the PDU. Okay, so we are just going to add a simple packet PDU from system 1 to system 3. For that, just click on this PDU. Click on this PDU once, and next click on the sender, as I want to send the packet from system 1. So our sender is system 1 and receiver is system 3. Done. And in here status, you can see the status of your communication, that the status is successful, no error. Okay, that means the packet is successfully delivered to system 3 and acknowledgement is successfully received to system 1 from system 3. But we can also check this communication through simulation. Okay, so then what's the benefit of using this simulation tool if we are not having the simulation how the transmission was done? Although it was successful, but we need to simulate this thing. So for this, in the right corner you have the option of simulation. This, so you need to click this simulation or shift S. After this you will be getting this type of window where you can have the controls to play the simulation. So here I am just going to play the simulation. This play, you can check system A has sent the packet to hub. Now hub will broadcast a packet to both systems, right? After these, system 2 has discarded the packet, but system 3 is sending the acknowledgement back to the hub. Now hub doesn't know where to send the acknowledgement, so it will again broadcast the acknowledgement to both systems. Now system 1 is keeping the acknowledgement and system 2 is discarding the acknowledgement. Okay, so this is how simulation is done. Simulation was done successfully, and here is the status. You can also delete the packet data unit by clicking on delete in the status window. Okay, so again let's send the packet from system 3 to system 2. Okay, and let's check the, here we got the successful, but we have to check with the simulation. So system 3 has sent the packet to system hub. Now hub will broadcast to both systems. System 1 will discard it. Now acknowledgement from system 2 to both 1 and 3. 3 will keep the acknowledgement and 1 will reject the acknowledgement. This is how the network is constructed and data communication happens between the connected devices. So next we need to build another network using switch and see whether it is whether the switch is going to set the unicast communication or multicast, or it is also doing the broadcast. So we have to check this with the simulation. So just we need to quickly add the devices. One PC, one laptop, another PC. Okay, and next we need to add a switch. For that I am searching a switch. I have taken the first one. This is our switch. So let's connect them with straight through cable with fast Ethernet port. Initially they were red. Now for one control is turned to green, means it is possible to communicate from PC 0, but switch is not able to receive now from PC 0 because we have red dot here. So it is taking some time to configure, and it takes time to configure. So don't worry, it will turn to green as the configuration is done. Ethernet second port, and last we will be connecting to Ethernet third mode. So here by the time we added these two devices, the first connection turned green and other two are still red. Okay, so we have to wait. For that time we can configure these devices with class C addressing. Network ID is same for all. So subnet mask is taken automatically. Quickly configure other device. You cannot provide same IPs to two systems in a network. Okay, configuration is done. IPs are provided to all the systems and the connections are also on, turned green. So we are able to communicate. So let's start with ping. Simply we need to ping the third system. And we have received the reply from the another system, that is system 3. That means our communication is okay. And we can also rename the systems like system 1, system 2, system 3. Okay, so here let's demonstrate the packet transmission or packet data unit transmission from system 1 to system 3. In the case of hub, it was broadcasted to all other devices except the source device. Let's check what we have with the switch. So this is our source and this is our destination, and we got the status as successful. But with the case when you are doing networking with switch, it may take time, so be patient. Now let's check it with the simulation. So here let's start the simulation. Packet is sent from system 1 to switch. Now switch is a smart device, active device. It will send the packet to system 3 only. Okay, and now system 3 will acknowledge it by sending the packet back to system 1 only. Acknowledgement. Okay, this is how simulation is done. Successful, we get the check. Now here is the status. You can delete the status and you can start the new transmission. We are going to start a new transmission from system 3 to system 1, a new PDU, packet data unit. Again the status is successful because our connections are okay. So let's begin the simulation. System 3 is the sender now and system 1 is the receiver. This packet is sent successfully. Now acknowledgement. And the acknowledgement is received by system 3. Okay, acknowledgement is just the surety that packet was transmitted and successfully to the destination. So destination send an acknowledgement just to confirm the successful receipt of the message or the packet. Okay, thank you. In next lecture we will be having more network simulation models with this packet tracer tool. Till then, bye and take care.